The green bonding screw in the 400 amp fuse disconnect can be considered the main bonding jumper. The screw provides a permanent connection between the ground and neutral systems at the service entrance. The screw is designed to carry the maximum fault current that can be delivered to the service equipment up to the ampacity of the connected conductors. Therefore, the screw meets the requirements for a main bonding jumper specified in National Electrical Code Section 250.24 AN. Installing a conductor between the ground and neutral in addition to the bonding screw is not necessary and would create a parallel path. The screw is sufficient to provide the required connection between the two systems. A main bonding jumper is a connection between the ground and neutral systems at the service entrance. A main bonding conductor is a conductor used to bond the grounded neutral conductor to the equipment grounding conductor. In most residential applications, the terms main bonding jumper and main bonding conductor are used interchangeably. The green bonding screw in the 400 amp fuse disconnect can be used as the main bonding jumper and meets National Electrical Code requirements. A separate conductor between the ground and neutral is not required and would create a parallel path. This screw provides a sufficient connection between the ground and neutral systems at the service entrance. When dealing with electrical systems, grounding and bonding are critical for safety and proper operation. Let's delve into the specifics of main bonding jumpers, their function, and how they relate to the neutral and ground systems, especially within a 400 amp fuse disconnect serving as the main service disconnect for a single-family dwelling. Firstly, understanding the role of the main bonding jumper is essential. The main bonding jumper is the connection between the ground and neutral conductor and the equipment grounding conductors at the service equipment. Its primary function is to provide a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices such as circuit breakers or fuses. This ensures that in the event of a ground fault, the fault current will quickly trip the breaker or blow the fuse, minimizing the risk of electrical shock or fire. Now, let's address the green bonding screw located within the 400 amp fuse disconnect. This screw is specifically designed and intended to serve as the main bonding jumper. It creates a direct and permanent connection between the neutral busbar and the equipment grounding busbar within the disconnect enclosure. This connection is crucial for establishing the required bond between the neutral and ground systems at the service entrance. The National Electrical Code, specifically Section 250.24 AN, outlines the requirements for the main bonding jumper. It mandates that the jumper must have the capacity to carry the maximum fault current that could be imposed on it. The green bonding screw, when properly sized and installed, is designed to meet this requirement. Its physical dimensions and material composition are chosen to ensure it can safely handle the anticipated fault current levels. Addressing the question of whether an additional conductor is needed between the ground and neutral in conjunction with the bonding screw, the answer is definitively no. Installing a separate conductor would create a parallel path for fault current. While it might seem like adding redundancy, parallel paths can actually be detrimental to the system's performance. When fault current has multiple paths to follow, it divides among them based on impedance. This can lead to a situation where neither path carries enough current to quickly trip the overcurrent protective device. This is a very important reason why a single, well-defined main bonding jumper is preferred over multiple parallel paths. Focusing back on the green bonding screw, it's important to emphasize that its design is engineered to handle the entire fault current. It's not a small, insignificant component, but rather a critical element in the grounding and bonding system. The screw size, material, and connection points are all carefully considered to ensure it can effectively carry the fault current and maintain a low impedance path. So, is a main bonding jumper and a main bonding conductor the exact same thing? The answer is yes and no, depending on the context. In most residential applications, the terms are often used interchangeably. However, technically, the main bonding jumper is the actual connection, while the main bonding conductor is the conductor used to make that connection. In the case of the green bonding screw, it serves as both the connection and the conductor. It's a physical component that directly bridges the neutral and ground systems. In larger commercial or industrial installations, the main bonding jumper might consist of a larger conductor, such as a copper busbar or a heavy gauge wire. In those cases, the distinction between the jumper and the conductor becomes more apparent. To summarize, the green bonding screw in the 400 amp fuse disconnect is indeed the main bonding jumper. It provides the necessary connection between the neutral and ground systems at the service entrance. Installing an additional conductor between ground and neutral is unnecessary and creates a parallel path which can compromise the system's safety and performance. The screw is designed to meet the National Electrical Code requirements for a main bonding jumper and can safely handle the anticipated fault current. When working with electrical systems, always consult the National Electrical Code and follow the manufacturer's instructions for proper installation and bonding techniques. Grounding and bonding are not areas where shortcuts can be taken, as they directly impact the safety of people and property. Let's examine the practical implications of these concepts further. When a ground fault occurs, such as a live wire accidentally coming into contact with a metal enclosure, the fault current seeks a path back to the source. The main bonding jumper provides that low impedance path, allowing the fault current to flow quickly and trip the overcurrent protective device. Without a properly sized and installed main bonding jumper, the fault current might not be sufficient to trip the breaker or blow the fuse. This can result in a dangerous situation where the metal enclosure becomes energized, posing a risk of electric shock to anyone who touches it. Furthermore, a prolonged ground fault can lead to overheating and potentially a fire. In the scenario described, with the 400 amp fuse disconnect feeding two 200 amp main breaker panels, it's important to ensure that the grounding and bonding are properly implemented throughout the entire system. The ground rods connected to the 400 amp disconnect provide a connection to earth, which helps to stabilize the voltage and provide a reference point for the electrical system. The separation of grounds and neutrals in the two 200 amp panels is also a standard practice. This prevents neutral current from flowing on the grounding conductors, which can cause nuisance tripping of ground fault circuit interrupters and create electromagnetic interference. The isolated neutral kits included with the 400 amp disconnect are designed to ensure that the neutral conductor remains isolated from the enclosure, except at the point where the main bonding jumper is connected. This further minimizes the risk of neutral current flowing on the grounding conductors. Now, let's consider some potential scenarios and troubleshooting tips. If you suspect that the main bonding jumper is not properly installed or is undersized, there are several steps you can take to investigate. Firstly, visually inspect the connection. Ensure that the green bonding screw is securely fastened and that there are no signs of corrosion or damage. Secondly, use a multimeter to measure the resistance between the neutral busbar and the equipment grounding busbar. The resistance should be very low, ideally close to 0 ohms. A high resistance reading indicates a poor connection or a missing bonding jumper. Thirdly, consult the National Electrical Code and the manufacturer's instructions to verify that the bonding jumper is properly sized for the service. The size of the bonding jumper is typically based on the size of the service entrance conductors. If you find any issues, such as a loose connection, corrosion, or an undersized bonding jumper, it's important to correct them immediately. A faulty main bonding jumper can compromise the safety of the entire electrical system. In addition to the main bonding jumper, other bonding connections are also important. All metal enclosures, raceways, and equipment must be properly bonded to the grounding system. This ensures that any fault current will have a low impedance path back to the source, minimizing the risk of electric shock. Bonding can be achieved using various methods, such as bonding bushings, bonding jumpers, and grounding screws. The specific method will depend on the type of equipment and the installation requirements. It is important to pay attention to the details of grounding and bonding and to follow the National Electrical Code and the manufacturer's instructions carefully. Grounding and bonding are not just theoretical concepts, they are practical measures that can save lives and prevent property damage. Firstly, ensure the green bonding screw is tightly fastened. Secondly, measure the resistance between the neutral and ground. Thirdly, verify the size of the bonding jumper against code requirements. Fourthly, check all other bonding connections in the system. Fifthly, consult with a qualified electrician if you have any doubts or concerns. Lastly, remember safety should be put at the top of the priority list. The electrical work can be dangerous, so it's important to take precautions to protect yourself from electric shock. Always turn off the power before working on any electrical equipment, and use appropriate personal protective equipment such as insulated gloves and safety glasses.